Hi, I Aziz welcome you to CoedMaster, and in this video I am going to talk about this problem. So let's get started. Alright, let's see this problem. We are given an array and we have to find leaders in a given array. Now the first question came to our mind that what is mean by leader and what is the criteria to say that this number or this element is a leader. So a number or element is said to be a leader if there is no element present to the right of it which is greater or equal to element itself. If an element satisfies this criteria, then this element is said to be a leader. Now let's understand this problem really well with few examples. Let's see this example. In this example we have given an array and there are these elements present in this array 10, 4, 3, 5, 1, 0. And you can see that 10 is a leader because there is no element to the right of the 10 that is greater than and equal to 10. Similarly, 5 is also a leader, 1 is also a leader, and 0 is also a leader because there is no such element to the right of 0 that is greater than or equal to 0. But 4 and 3 are not leaders because if I consider 4, there is an element 5 that is greater than 4. And if I consider 3, there is element 5 that is greater than 3. So the output of this input is 10, 5, 1, 0. Okay, now let's move on to next example. In this example, the elements are arranged in increasing order. So what happens when elements are arranged in increasing order? In this case, only last element is going to be the leader. Why? Because if I consider 1, then there is a element 2 that is greater than 1. If I consider 2, then there is element 3 that is greater than 2, and if I consider 3, there is an element 4 that is greater than 3. So in this case only the last element is going to be the leader. Moving on to next example. In this example these elements are arranged in decreasing order. In case if elements are arranged in decreasing order, all elements are considered as an leader. Why? Because if I consider number 4, then there is no element to the right of this element that is greater than or equal to this element. That is why 4 is a leader. Similarly, 3 is also a leader, 2 is also a leader, and 1 is also a leader. Okay, so I hope now you have good understanding of this problem. So let's pause this video and think about an algorithm to solve this problem. Alright, I hope by now you would have written at least basic program to solve this problem. So let's first discuss the brute force approach to solve this problem. The idea of brute force approach is pretty simple. We have an array. In this array we have elements like 10, 4, 3, 5, 1, 0. Okay. The idea is we are going to traverse this array from 0 to n minus 1. We pick one number at a time and then we traverse this array again from the next number till the last number. And we try to find a number that is greater than or equal to this number. If we found any number that is greater than this number, then we can say that this number cannot be a leader. Okay, and if we do not able to find any number that is greater than or equal to this number, then we can say that this number is a leader. So this is the simple idea to solve this problem. Let's see the implementation of this simple approach. Here we have a function and this function is taking array as input. In the first statement we are getting length of array by using length property of array, and then we are running a loop from 0 to less than n. And inside of this loop I am initializing a variable exist to false. So here I am assuming that there is no such element that is greater than or equal to the element we are traversing. And then again we are running a loop from I plus 1 till less than n. Okay. And inside of this inner loop we are checking for each item that if this item is greater than or equal to the selected item or not. If we found any item, then we simply set the variable exist to true and break the loop. And after this loop we check if element exists or not. If element does not exist, meaning if any element greater than or equal to does not exist, then we simply print the element. Okay. And if we found the element that is greater than or equal to the selected element, then we simply break the loop. What I mean by selected element? So in the outer loop what we are doing, we are picking one element at a time and then we are searching towards the right of it. Okay. Now let's quickly try run this code and see how it works. So let's say the array is given as 10, 4, 3, 5, 1, 0. These are the indexes of the array. In first iteration the value of I is 0. Element present at 0th index is 10. So we are going to traverse from first position till 5th position and try to find any number that is greater than or equal to 10. And this time we do not found this number, so we print 10 on the screen. In next iteration our I becomes 1 and the element present at index 1 is 4. So what we do, we traverse from index 2 to 5 and we found that there is one element 5 that is greater than or equal to 4. So we are going to break this loop and move on to next iteration. In next iteration I becomes 2. There is so at index 2 we have 3. We are going to traverse from 3 to 5 and check if any number that is greater than or equal to 3. We found that there is one element 5 that is greater than or equal to 3. So we are going to break this loop and simply ignore this number. This number, meaning this number cannot be a leader. Moving to next iteration, in this iteration our I becomes 3. There is an element 5 at index 3. So we are going to search from 4 to 5 this time, because every time we are searching from next element, right? And this time we do not found any element that is greater than 5. So we simply print it on screen. Moving on to next iteration. In next iteration our I becomes 4 and element present at index 4 is 1. We again go to right of it and try to find any number that is greater than or equal to 1. We do not found this time. So 1 get printed. So we simply prints 1 on the screen. In next iteration our I becomes 5. Element present at index 5 is 0 and there is no such element to the right of 0. That is why the 0 gets printed on the screen. So finally all the leaders get printed on the screen and these are 10, 5, 1 and 0. Okay, alright. So talking about the time complexity, we are running two loops. One is outer loop and one is inner loop. Both the loops are running n times and this is the nested loop. That is why the time complexity of this function is going to be big of n square, because whenever we have scenario like we have nested loop, we simply multiply the time taken by both the loops. Okay. Now talking about the space complexity, we are not using any extra space, so the space complexity remains theta 1. Okay. So to solve this problem using brute force approach, this solution took big of n square time and theta of 1 constant space. But can we do it better? Can we solve it in big of n time? So do one thing, let's observe the given problem and think about a solution that can solve this problem in big of n time. And I hope that after observing this problem carefully, you are going to get some idea that is going to help you to solve this problem in big of n time. Alright, now let's see the efficient approach to solve this problem. Okay, so here is the idea to solve this problem efficiently. We are given an array 10, 4, 3, 5, 1, 0. Okay, and the fact is we know that the last element is always going to be leader, because there are no such element to the right of it that is greater than or equal to this element. It means the last element is always going to be leader. Now what we do, we are going to traverse the array from right to left. Instead of 0 to n minus 1, we are going to traverse n minus 2 to 0, because this element is n minus 1, this element is n minus 2. Okay, we are already considered this, we have already considered that n minus 1 is already a leader, so we do not have to traverse this number again. We are going to traverse from here, and so we know that the current leader is 0, right? Next we are going to traverse this array from this number to 0. And in each iteration, we keep track of the current leader. So for example, if we get number 1, we check that our current leader is smaller than 1 or not, means 0 is smaller than 1 or not. Obviously 0 is smaller than 1. It means we have to update our current leader. So we update the current leader to 1 and we print it on the screen. And if the 0 is greater than or equal to 1, then we have to simply ignore it. Let's say we have got number like this 2, 1, 0 and 2 is our current leader. Then when we move to this number, we can say that 2 is the greater than this number. So in this case, we just have to ignore this case, because 2 remains our leader till 0. Okay. So this is our efficient approach and we are going to follow this process to solve this problem. Now let's see the implementation of this efficient approach. Again, we have a same function that takes array as input. Now in this function, what we are doing, we are first storing the last element in current leader variable, because the last element is always going to be the current leader, and we simply print it on the screen. And then we are running loop from n minus 2 till 0. Okay, and in each iteration we are checking if our current leader is less than or equal to new element or not. If we found any number that is greater than current leader, then we have to update our current leader, because the previous current leader is no more current leader now, because we found a number that is greater than current leader. And then we simply print it on the screen. So let's quickly run this code and see how it works. We have this array 10, 4, 3, 5, 1, 0 and these are the indexes of this array and n is equal to 6. Now first what we are doing, we are storing the last element in the current leader variable because this is our leader. So we print it on screen like this. And then we begin our loop from n-2. n-2 is what? It is I. It is equal to 4. So I equal to 4. At fourth position we have 1 element. We check if 0 is less than 1. Yes, it is less than 1. So it means 0 is no more our current leader. We have to update our current leader to 1. So we update the current leader to 1 and print it on the screen. Okay. In next iteration our I becomes 3. At third position we have element 5. We check if 1 is smaller than 5. Yes, 1 is smaller than 5. It means we have to update our current leader to 5. Now our current leader is 5. Moving to next iteration, our I becomes 2. At second position we have 3 element. We check if current leader is smaller. This time current leader is greater. So we just have to ignore this case. In next iteration our I becomes 1. At first position we have 4. Again we check current leader is less than 4 or not. This time current leader is greater. So again we have to ignore this case. So our current leader remains 5 till now. Then in next iteration our I becomes 0. At 0th position we have 10. We check if current leader is smaller than 10. Yes, this time current leader is smaller than 10. It means we have to update our current leader. So we update the current leader and print it on the screen. So this is how we get all the leaders printed on the screen: 0, 1, 5 and 10. So far so clear. Now talking about the time complexity of this function. Here we are doing some constant operation and then we are running a loop from n-2 to 0. So it means this is going to be so here we are doing theta 1 work and here we are doing n work. So the time complexity of this function is going to be theta of n, and as we are not using any extra space, the space complexity comes out to be theta of 1, that is constant space. So using this efficient approach, we have solved this problem in theta of n time complexity and theta of 1 space complexity. Great. Okay, so before we end this video, let's have a quick recap of what we have learned so far. So we are given a problem, and in this problem we are given an array, and our task is to find leaders of an array. And what is mean by leader? An element is said to be leader if there is no such element present to the right of array that is greater than or equal to that element. Okay, so to solve this problem we saw the brute force approach, and in this approach what we did, we pick one element at a time, go to the right of itself to find the number that is greater than or equal to 1. If we found the number, then we say that this number cannot be a leader. If we do not find any number that is greater than or equal to this number, we declare that this number is a leader. And to solve this problem, this approach took big of n square time to solve this problem. After brute force approach, we moved to efficient approach, and in efficient approach we first store the last element as a leader, and then we traverse the array from the last element to the first element. And in each iteration we check that if the current leader is greater than, and while traversing array from the last element to first element, we check in each iteration that if current leader is less than or equal to new element or not. If new element is greater, then we reset our current leader to that element. And using this approach, the time complexity came out to be theta of 1. So I hope you have a good idea of how to find leaders of an array. So this is it for this video. Thanks for watching. See you in the next video.